Okay, so what about something like this? We want to calculate y double prime. Now, finding y prime would be no big deal using implicit differentiation, right?
Yeah.
Okay, and what is the second derivative?
2x plus 2y prime.
Well, I mean, I don't want a specific answer, but I want to know what is the second. The first derivative is just dy dx, right?
Yeah.
That's
True.
what is the second derivative? How is it related to the first derivative?
2y dx prime.
Say it again.
The derivative of that.
Okay, good. It's the derivative of the first derivative, right? Okay, so then, even if we're using implicit differentiation instead of explicit differentiation, which we're now doing for something like this, right? Whenever y is not isolated, we're just going to differentiate implicitly and isolate y prime in our answer to get y prime, right? So, would you agree then, it makes sense if we want to calculate y double prime, the first step is probably going to be to what?
Find y prime.
Yeah, find y prime. Sure, we're just going to differentiate implicitly once, and then we'll probably have to do that again, right? So if we implicitly differentiate once, what do we get? This first term is going to give us 2x. Good. Second term is going to give us
2y prime.
2y prime, and third term gives us 0. Okay, so what could we do to simplify here, maybe? Okay,
Divide by 2.
Okay, we could divide by 2, couldn't we? We could divide both sides by 2 and cancel that out. So we're left with x plus y prime equals 0. Okay? Now we've got a choice. And I'm not sure really that either option here is clearly better than the other. We've got to find y double prime. So what's a suggestion? What's something that we could do? We could just jump right into that and implicitly differentiate again, right? So let's do that. So what do we get if we differentiate again? First term gives us 1. Okay, now second term. Gotta be a little bit careful with the second term. It's the product rule, isn't it? Right, so we've got the derivative of the product of y and y prime. So how are we gonna do that?
Why do you have to do the product rule? I'm sorry.
Because this is a product of two things,
Gotcha.
right? Okay? So what is the product rule going to give us then? We've got first times derivative of the second plus something else. But let's just hold there for a second. So what's the first part of the product rule going to give us? Y times y double prime plus y prime times y prime equals 0, right? Or in other words, let me pause there. Does that make sense? Think what we did. We just took the derivative. Okay.
Can you say it one more time?
Sure. So we took the first factor is y, the second factor is y prime, right? So we've got first times derivative of the second plus second times derivative of the first, right? And so we could simplify this a little bit by maybe rewriting it as 1 plus y double prime. How could I rewrite that?
Y double prime? No.
2y prime.
No, it's not 2y. Yeah, it's y prime squared. Yeah. Right? Anything times itself is just that thing squared, right? Okay, so now all we have to do is isolate y double prime, right?
Yeah.
Okay, no big deal. So we get subtract 1, and then subtract that, right?
Y.
And then divide by y, right?
Oh my.
So we get y double prime equals -1 minus y prime squared, all divided by y. Agreed?
Yeah.
Where did the y go?
I had to divide it away, so I got rid of this term and that term by subtraction, and then divided both sides by y.
Okay.
Okay, now, yes, look.
How would you enter like a y prime?
Okay, good question. So how would we enter a y prime? Now, in cases where you can do that, I allow you to have, I put a prime in there so you can enter the prime, I think. in Math Excel, pretty sure it is. It's gonna be a little button on the side that you could choose that would be the prime button. You could always write a y prime as a derivative too, right, as a dy dx. But here's my question, is that even necessarily okay to do?
No.
Maybe not. I mean, it might be and it might not be, just depending, but it's likely that you're gonna be faced with a situation here where we're gonna wanna know y double prime as a function of x and y, not a function of x and y prime.
Does that mean you just plug in when you got y prime?
Exactly. Yeah, so we've got to backtrack a little bit. We've got to backtrack up to here, don't we? And what really would the other option have been here? The other option would have been, instead of just differentiating implicitly, again, as Clancy suggested, which was a good suggestion, we could have also isolated y prime, solved for y prime, and then differentiated both sides, right? Either way would be fine. I kind of like this way personally, the way that we did it, but we do have to be able to substitute. So we have to go back to the original, well, not the original, we have to go back to the equation that we got when we first implicitly differentiated, and we have to isolate y prime. What are the two steps we would do to isolate y prime?
Minus x and then divide by y.
Okay, so would everybody agree then that we just get y prime equals negative x over y?
Yeah.
Wait, why didn't we just do that? It's so much more simple.
And you have to use quotients.
But,
Some
okay.
people don't like doing that.
Right, so even if we did do this, it looks like it's gonna be simple, but it's not really.
Oh, it's not.
We're gonna get, when we differentiate, we're gonna use quotient rule, and we're gonna get y primes in there anyway, right? So we're still gonna have to go back and plug that in,
Okay.
right? Either way is fine, but now all we have to do here is plug that in to our final answer for y prime, and then we'll eliminate the y primes by substituting for x's and y's, right? So we'll eliminate the variable by substitution. So what's that gonna look like then? So we're gonna get 1 minus that quantity squared. Oh, -1, sorry, -1 minus, why do you say positive?
Would it be plus?
Two negatives.
Okay, but is it a negative? Because this is being
Yeah, you
squared,
have to square.
Oh.
right? Divided by y, right?
Right.
And so that's gonna give us, what? It's gonna give us -1 minus, what is the quantity negative x over y squared? Everybody agrees positive x squared over y squared? Right.
Sure, yeah.
Well, no, but if I square a negative, it comes out positive, doesn't it?
but you know.
So then you can.
Oh, that's a negative, right, because that's not being squared. So minus the quantity x squared over y squared. I don't even really need to have the parentheses there, do I? No, I can get rid of them.
Wait, can you go up?
Sure.
Wait, why are we doing that?
Didn't you read it how it was?
Can I leave it like that?
Yeah.
Well, I mean, I could maybe. But that's not, I mean, we can simplify that. Eventually, we're gonna have to. And that's still kind of an ugly way to write it. We don't wanna have, we really don't wanna have fractions divided by fractions. But we know our strategy is always the same for simplifying fractions divided by fractions, right? We just simplify the top, make one big fraction on the top, one big fraction on the bottom, and then what?
I don't think there was a strong.
No, it's no big deal. We've done this, we'll do it again, yeah.
Okay, I know this is not intentionally, but then could, oh, never mind, actually, never mind. I was thinking, because we got an x squared plus y squared at the start, you could simplify it, but never mind.
Oh, okay, no, okay, I got what you're saying. Okay, but now, on the top here, so this is what we're left with in the numerator. That's really not probably good enough, right? That's pretty, I mean, we got a fraction in the numerator, we've got a fraction, y over 1 as a denominator. So our goal is always to just simplify the numerator, write it as one big fraction, simplify the denominator, and then flip and multiply, right? So what's that give us? Well, on the top, I just have to get a common denominator, right? So aren't I just gonna write this as negative y squared over y squared minus x squared over y squared?
Yeah, I do.
Okay? So then this just looks like negative y squared minus x squared over y over y. Well, I've got a common denominator, right? So that gives me negative negative y squared minus x squared. Let's just flip those around and put the x first, not that it makes any difference. So that's my numerator, right? Pause there. Everybody agree?
Wait, why do you still put the y squared on the bottom?
Because it's a common denominator,
Okay.
right? When I add fractions, the common denominator stays the same, right?
Okay.
Okay, everybody good with that?
Yeah.
On the bottom, I've just got a y over 1, right? And so all I have to do then to get my answer is just flip and multiply. So I'm going to get negative x squared minus y squared over y squared times 1 over y. And what's that going to look like?
Negative x squared
Negative, yeah, negative x
minus
minus y squared over y cubed.
Yeah, negative x squared minus y squared times 1 doesn't change anything. On the bottom, y squared times y
is y cubed.
is y cubed.
Wow, that is confusing.
Okay, kind of, but you folks are getting to a point where that kind of stuff is okay for you now. I mean, that's
No.
really, all you have to do with math is just don't get intimidated. We didn't do anything really hard there. It's just a lot of steps strung together. But don't wig out. Just follow the steps and you get to the answer. So what if, though, this is going to look harder, but I'm going to claim this is easier. What if I gave you something like this instead? What if I said, what if I took the original problem and I did something easier? I said instead, calculate the value of y prime when x equals something and y equals something. How about? Okay. Right, so I'm gonna, let's see, score. Okay, yes, we'll do this. Okay, what if we did that? What if we said let's find y prime, find the value of y prime when x and y have those values?
Which is the exact same thing, but in the
We're going to do a lot of the same stuff, aren't we? Right? So we could have gone, in fact, most of it could have been the same. I can go back to this last page, and I can grab a lot of the same work that we did before. A whole lot of the same work. In fact, I could,
We can do all of it and then put it.
almost,
Yeah.
almost. We can go right to there. So
Math is me.
Y.
It's our candy cane.
Yep. All those fancy tricks? Just trial them. Just messing around. Okay, so how about this? Now, would I have to really simplify this a whole bunch? No, because whenever I'm evaluating something, that means I'm plugging in numbers, right? It's easier to calculate the numbers and just plug the numbers in than it is to go through that whole process of rewriting in a simplified algebraic form, right? So if I know the values of x and y, look what that's already taken care of. That's already taken care of those two terms right there, right? All I have to do is plug in y prime. But if that's y prime, I can find a value for y prime as well, right? Y prime equals negative x over y. So when x equals the square root of 5 and y equals negative the square root of 5, y prime equals positive 1, doesn't it? Because I'm going to get negative square root of 5 over negative square root of 5, right? Everybody see that? Negative square root of 5 over minus root 5. So y prime equals positive 1. Right? So all I have to do then here is just plug this value in there and that value in there, and I get a numerical value, right? I'm just going to get what?
Negative 2 over.
Yeah, good. So negative 2 over the square root of 5, which is fine if we wanted to.
Yeah, but wouldn't the whole thing
Oh,
be positive?
yep,
then?
you're right.
Yeah.
So then it becomes positive. And then if we want to rationalize the denominator to make it look better, what would I do?
Times by
Times by square root of 5. 2 square root of 5, okay.
So I just get, right, 2 radical 5 over 5. Okay? That's it. So that was actually much easier.
But that's because you did all the work for the other
Yeah,
one.
'cause you did all the work ahead of time too.
Okay, sure, but we did get to, so all you have to do is just have the work already done, and then it's like, no, but we didn't have to do any of this stuff, right? We got to skip all of that.
To the other guy, we just go and
Yep.
Please
Yep.
hold on.
Okay, let me scroll down first. That's first page, right? That's page 1. Is that what you wanted to see?
No.
Page 2?
Yeah.
Okay.
So that would be your final answer. Are you sure you don't want to move the test back?
No, I'm positive. I want to do one of them before we go.
2, negative 1 minus 1. Can I ask a question?
Yep.
Are we gonna have a semester final?
I don't know.
Why would you bring that up?
I sort of, honestly, at this point, I'm not really planning on it.
Good. Yeah, we don't. What is learn that?
Yeah, I doubt it. With calculus, it all kind of, I mean, every test you take is kind of a final in a way anyway, so.
Great.
On the bright side. Okay.
Hey, tomorrow Christmas ornament day?
Tomorrow's no day.
Oh, yeah. When's Thursday's Christmas?
Wednesday's Christmas.
Thursday's Christmas ornament.
You know, like those ornaments you decorate your room with a picture of your face. Wear that around your neck. And then wear like a bow in your hair.
Yeah, I think that's good.
Yeah, that's good. Woo!
Yeah, after I was